Hello everyone, welcome to the next lecture on digital surface models and digital terrain models. When drone survey data is processed using photogrammetry, one of the most valuable outputs is elevation information. This elevation data helps us understand the shape, height, and structure of the landscape. Two commonly generated elevation models are digital surface models and digital terrain models. While they may sound similar, they represent different aspects of the landscape. Let's explore what each of these models represents and how they are used. What is a digital surface model? A digital surface model or DSM represents the elevation of everything on the Earth's surface. This includes not only the ground but also objects located on top of the ground, such as buildings, trees, power lines, vehicles, infrastructure. In other words, a DSM captures the topmost surfaces that the drone camera sees during the survey. For example, if a drone flies over a forest, the DSM will show the height of the tree canopy, not the ground beneath the trees. DSM data is extremely useful for analyzing structures and surface features. Common uses of a DSM include urban modeling, infrastructure planning, building height analysis, communication tower planning, solar panel placement studies. Because DSM represents the true visible surface, it is often used in applications where structures and objects need to be measured. What is a digital terrain model or DTM? A digital terrain model represents the bare ground surface with objects like trees and buildings removed. In this model, the software attempts to filter out surface objects so that only the underlying terrain remains. For example, if the drone survey covers an area with trees, the DTM will attempt to show the ground elevation beneath the trees rather than the tree canopy. This makes DTMs extremely useful for studying the natural shape of the land. Common uses of DTM include land development planning, flood risk analysis, drainage modeling, road and infrastructure design, terrain slope analysis. Because DTMs focus on the true ground elevation, they are essential for many engineering and environmental projects. Key difference between DSM and DTM. The main difference is simple. DSM includes all surface objects like buildings and trees. DTM represents only the bare earth terrain. Both models are valuable, but they are used for different types of analysis depending on the project goals. Why these models matter in drone surveying? Drone surveying provide a powerful way to generate high resolution elevation data quickly and efficiently. By using DSMs and DTMs, professionals can better understand the topography, structures, and terrain characteristics of a surveyed area. These elevation models are essential for engineering design, environmental analysis, construction planning, and infrastructure development. In the next lecture, we will explore another important output of drone photogrammetry: point clouds and 3D mesh models, which form the foundation of detailed 3D mapping. Thank you.